Hey everybody, and welcome back. So this evening what we're going to talk about is the airfoils that I've used. Basically the way I design the tails on my airplanes, you know, the links and everything. And then talk about a little bit about aircraft stability. And I really want to say this is just what I have done and works for me. Your mileage may and probably will vary. Just to make sure that everybody understands that I'm talking about just my experience here, okay? So let's get this rocket launched. So we're going to talk about airfoils, tail design, and stability. And I'm going to jump right into this so that we don't sit around all night just hanging out. So when we think about the airfoil, I have learned that it just doesn't matter that much, okay? If you've got either a semi-symmetrical or a flat bottom wing, which is like a Clark Y, and we'll talk about airfoils, dive into it. On model aircraft, because of their size and their cube wing loading and what we're doing with them, it doesn't matter that much. In full-scale aircraft, the airfoil is to get the absolute best amount of lift for the most efficiency through the air. And we don't care about that with model aircraft that much. Now, if you're building a high-performance glider or a slope soarer or something like that, airfoil may make a difference. But I'm talking about scratch building, general aviation, warbirds, homemade contraptions. I'm just talking about in general. The airfoil does not matter that much. And keep in mind, there was a couple of things about airfoil design from the 40s up until now. A plane like a B-36 had such a thick airfoil. Yeah, it was to lift the weight, but also they had to put enough fuel in there for the bomber to get all the way to Russia and back without refueling. There was no air-to-air refueling when the B-36 was created. So there's a lot of things that came into that. So this is what doesn't matter. I had a person one time look at the front profile of the plane and goes, oh, that airfoil is way too thick. And I said, what does it matter? Well, it just looks silly. Well, you know, we don't know why the person built such a thick airfoil. So if you got a model and you got a thicker airfoil and it flies the airplane, who cares? For some reason in people's minds, they think we got to have the thinnest airfoil. And there's all kinds of problems with thin airfoils. They don't produce enough. They don't produce as much lift. They have pointier noses, so they stall more abruptly. A big round nose, the air takes a while to figure out which way to go. On a pointy nose, it decides pretty quick. So most airfoils that you pick for your airplane are going to work, okay? And there's only 5 or 6 that I ever use, and I'm going to show those to you in a minute. So let's dive into it because, look, I'm really passionate about making this super easy, especially if you're a newbie. I mean, there are styrofoam planes flying that don't even have an airfoil, and they fly decent, okay? I mean, I'll never forget when I got some of the flat foam type airplanes that didn't have airfoils I flew with little electric motors in my house. They flew pretty daggone good. Now they won't go quick because they'll flutter because there's not an airfoil there, but they flew. And if you remember what we called, what was those airplanes back in the late 90s or mid 90s called? I think we called them, not lawn darts. Well, yard dart was a thing you threw and it would stick in your brain, kill you, and they made those illegal. Maybe it was a yard dart. I don't know, but it was a plane that had a flat wing. If you went fast, it would flutter itself to death. Flew on like a 30 engine or a 35. But let's get in and talk a little bit about the airfoil here. First, I want to talk about my sponsor, RTL Fasteners. Fantastic people. If you need servo screws, bolts, nuts, blind washers, any of that stuff, go to their website. If you buy more than $50 of product, you can get 30% off by using code DA30. So let's move on. Great people, by the way. So when we think about the types of airfoil, I'm going to start off here with a Clark Y. Now this looks a little funky because I used a program called CompuFoil, and CompuFoil lays out the rib with the airfoil chord at 0. Okay, it doesn't show the incidence of the wing in the drawing. You do that when you put it into something, and I'll give you an example. So this is a Clark Y, which I call this basically a flat bottom wing. But when you put it on the aircraft, this is the way the incidence would be set up, about 2 degrees positive incidence with the flat bottom of the wing on the fuselage. This is used in Cubs. I've actually stuck this on warbirds, and it works great. You got to ask yourself, what do you want your airplane to do? For me, I want it to fly, I want it to land, and I want to be able to repeat that many, many, many times, okay? When you build high-performance, thin wings to go fast, they're harder to land. There's a lot of things that you create problems for yourself than if you're just going out to have fun, you don't need it, okay? So this is actually a Clark 15, which most people haven't heard of. It's a little bit thinner version. And then there's the Clark 59, which some of my friends have used on gliders, go fast gliders, or speed planes, whatever you call them. Well, they're gliders and some are made for speed. But the NACA 007 is a fully symmetrical. This would work on a go fast plane. But I use this 99% of the time for my vertical stabilizer. People always forget about the airfoil shapes of the stabilizer. Some people want the horizontal stab to be a flying stab, which I've seen a lot of people do. There's a lot of controversy, and as the plane goes faster, both surfaces are flying. And I'm not going to get into that because that's a huge rat's nest. But this is the airfoil I love for my vertical stabilizers. This is one I use on both horizontal and vertical stabilizers. This one, which is the 10 or the 010, I've used this as horizontal stabilizers on 80% of my airplanes. Okay, the MSL2 has this as the horizontal stabilizer, except I've rounded the front a lot more. It's not a very pointy tip on the stabilizer. And this right here actually was the airfoil I used on my C-130, but I gave it a 3.5 degree positive incidence. I'll show you later on how I do that on some of my other airplanes. But these are just basic airfoils, fully symmetrical airfoils. But if you want to get into kind of massaging airfoils in this program called CompuFoil, you can take a fully symmetrical wing and start to make it a semi-symmetrical wing. And keep in mind, there's something like 2,000 airfoils out there you can choose from. But I've only got like 6 or 8 that I go to 99% of the time. So here is what it would look like if I was going to cut it out with a bandsaw and use it and also have the wing jig. This is where I'm starting to make it semi-symmetrical. And I've used this airfoil a lot. And then that's what that looks like if I was going to cut it. And then this is where I get it as semi-symmetrical as I like, but still have a little bit of a rounded bottom. This airfoil is awesome for like a plane you're going to be lifting, like a cargo plane. Let's say you're scratch building a Frankenstein plane that you want to carry cargo. This is a great airfoil. It's got a lot of lift. It's got a very round leading edge. It's very forgiving. But there's no math here because this program, honestly, if it looks right, it's going to work for a model aircraft. Keep in mind, with a model aircraft, the smaller you get it, the less molecules are touching the wing surfaces. Okay, that's the reason we went to cube wing loading. You know, some people get mad and say, well, it doesn't work on full scale. Cube wing loading was never invented for full scale. It was invented as a way for model aircraft to know how your smaller airplane is going to handle versus a larger model airplane, in how the weights matter with the way the plane's going to perform. So when you start to look at a wing like this and you put it on just about any model airplane, you could put this on a P-40, you could put this on a P-51, you could put this airfoil on any model airplane. It's going to land beautifully as long as it's somewhat light. When you go fast, you're going to have to hold down a little bit of elevator, but most of our planes we do. So honestly, if it looks like a good airfoil, it's probably going to be fine on your model airplane. But keep in mind, full-scale airplanes, the reason they care about the airfoils is they want as much lift with as much efficiency as they can get because they want it low fuel cost. Or they want it to be a certain performance, like for a STOL aircraft or something. But for models, you know, this is my go-to airfoil. That's what it would look like if I was to plot it out. I was going to cut it out. But here's what I want to show you, something that's interesting. This is the big T28, the 150H T28 I'm designing. And I decided on this to use a fully symmetrical airfoil. but I'm going to put a pretty high, about 3¼ degree incidence on it, so it will look like this. The reason I'm doing this is I want this airplane to go fast. I'm going to put about 15,000 watts of power in this. It should do about 120 mile an hour level flight, and that's fast for a 150-inch wing airplane. But the reason I did this fully symmetrical is because as I'm going fast, I won't be having to hold quite as much down elevator. How do I say this right? When you've got a flat bottom wing, the faster you go, the more lift you're going up. A fully symmetrical wing that has a 3 degrees up incidence, if you get that down to about a ½ degree incident and go fast, it doesn't want to keep climbing. You got a lot better ability to go fast without it always wanting to climb. You always trimming the nose down. So that's one reason on this I'm using a fully symmetrical wing, because when I go fast, I won't have to use so much energy or forces to keep the nose down and go fast, if that makes sense. So now what I want to talk about is the tail design. And I've gotten more emails and requests about this than most subjects. And there's nothing voodoo witchcraft here, okay? If you're scratch building your own airplane, the things you got to remember enough is, do you have a long enough nose moment to get your CG right? Most of the time the length of the nose is because of the weight of your motor, and to get the CG right. Most of the time the tail is going to be 40% of the fuselage from the trailing edge to the leading edge of the horizontal stabilizer. All of this is basic math you find on Google. If you want to know how to build a basic airframe, this is the information right here. The fuselage length is normally 75% of the wing. If you watched my designing an airframe, you've seen all this before. Okay, the nose length is normally 20% of the fuselage length. This is for model aircraft though. Our motors are a lot lighter than full-scale engines. Well, I shouldn't say that. I was going to say relatively speaking, but some of our electric motors are really heavy. They're heavier than a gas motor. But as a rule of thumb, 20%. From the trailing edge of the wing to the front of the stabilizer is normally 40%. Horizontal stabilizer area is normally 25 to 30% of the wing. And that's really important to keep in mind, because if you have a shorter moment arm, keep in mind how a crowbar works. The shorter your tail is and the smaller your horizontal stabilizer is, the less counteracting forces you've got to keep the plane pitch under control. And that's where people say, oh, I built an unstable airplane. 90% of the times it's not the size of your stab or the length of your tail. You've got your servo throws all screwed up. Your servos are hauling ass because you've got a really high performance servo. You're not using exponential. Your CG might be off a little bit. Your thrust on your engine might be off a little bit. There are so many things that can cause an unstable airframe that a lot of time it's not the airframe design. Okay? Somebody said to me, well, you have to have a long tail. I'm not looking at an F4 or an F111. They have huge horizontal stabilizers, well, stabilators. And if you think about where the wing is in relationship to where that stabilator is, it's not that long. So most of the time when you have an unstable airplane, it's not the airframe. It can be a contributor. So if you remember my designing an airframe video, I have created a calculator that tells me how big my elevator should be, how big my ailerons, how big my rudder, all those usual suspects. But that is just generally speaking. If you're going to have an airplane that has a short coupled tail, you want big elevators and a big stabilizer. You want more control. But you don't want 35 degrees of elevator throw on a high-speed servo without any exponential. And I know some of you have said, oh, I've flown 30 years without exponential. Congratulations, that's awesome. 90% of my friends fly with exponential that flies any type of high-performance plane or experimental plane or a scratch built. Anything that you make yourself, once you get it tweaked out perfectly, I would say almost 100% of my friends use exponential. Okay, that scratch build and stuff. So here's where one of the rules don't apply. When you've got jets, this math down here doesn't really apply. It does on the square inches or square feet of the stabilizer to the wing, but the moment arms and everything get a little bit wonky. But now what I want to do is talk about true stability. And I'm going to always refer to a little bit of the tail, because look, the tail isn't any kind of special. Hang on, let me back up for a minute before I jump into this. There is no magic in the tail of the airplane. It is a crowbar. It's a cantilever that's trying to control the pitch at the center of gravity of the wing. Okay? So if you think about where the center of gravity on that wing is, you got a motor out here and you got a tail. Most planes that pitch up taking off are not tail heavy. Watch my CG video. You've either got the incidences screwed up or you've got way too much throw. I've seen servos move so fast they could drive a nail into a board. And if you don't have exponentials or something kind of soft in the middle, you may be creating a pilot-induced oscillation and you're screaming, my CG's off. No, it's not, knucklehead. It's the way you got your plane set up. But it's hard to get the tail wrong. If you've got enough square inches and enough moment arm, and you've got enough elevator, to control the pitch, you should be fine. So now let's talk about stability for a little bit. I love the 190, okay? And one thing I love about the 190 is it's got a long tail, and the nose had a big radial engine in it, so a lot of that was to get the CG right. But by having a long tail, it was a very pitch stable airplane. And when you think about what you're wanting a model airplane to do, is you want it to fly and you want it to land, and you want to keep repeating that. I've said that in a lot of my videos. I think I already said it in this one. You want a good flying airplane. Nobody intentionally wants a bad flying airplane. I had a friend that had one of these, and it was one of the greatest flying airplanes I ever flew. I had another friend that hated the plane, and I'm like, why do you hate it? Oh, it's hard to land. It was a little bit heavier, but the thing I liked about it was so stable with that long tail. You could put this airplane anywhere you want. But I also want to talk a little bit about what is considered easy. Okay, when you think of stability, if you have a trainer, your CG's right, your incidences are right, your throws are right, the plane flies right. So why would your scratch build that virtually has these same exact proportions not fly right? Well, it's probably your throws or your center of gravity. Could be your incidences. Too many people invent an airplane that is basically a replica of like a P-40 or a Cessna and just says, oh, I screwed something up, it flies horrible. It's probably the radio. I mean, I hate to say that. I'm not making fun of anybody. But, I've test flown a lot of airplanes, and the person says, this plane is really, really hard to fly. Once I set up the throws, put a little bit of exponential in it, might have to change a little bit of, you got your horn on your elevator or aileron or rudder. I might move it in a little bit so that you get a little bit more throw or a little bit less throw. Me personally, I only like 20 degrees up and down on an elevator, unless it's aerobatic. Sometimes you can stall it. If you go to 45 degrees, chances are that elevator's not even really doing that much unless you're in a true hover mode. If you're flying through the air and you got 45 degrees of up elevator, I'm not going to judge you. That's just not the way I do it. I've seen these airplanes fly like complete garbage. And I don't want to sound egotistical, but you give me an hour with it and I get the center of gravity right and the throws right, these things fly like cubs. Okay, so I've always considered any biplane, as long as I got to be careful. I open up this wormhole or can of worms. A lot of biplanes, depending on where the top wing is, will either have positive top wing incidence or a little bit of negative. But it has a lot to do with where the wing is relationship to the other wing. Some biplanes that have ailerons on the bottom wing want the top wing to stall first. That way you don't ever lose aileron authority. So the top wing is actually 1 degree higher than the bottom wing. But I'm not going to go into all that right now. I'm just saying, I've known people that have built albatrosses, Fokkers, and all this and say these things fly like crap. They don't if you set them up right. Now, they're not self-leveling airplanes. When we talk about stability, if you got a 172 with dihedral, let off the sticks, pretty in the next 30 seconds, it's going to try to level itself out. I've flown some biplanes that if you leave it in a 30-degree bank, it stays in 30-degree bank until you fly it back, because they don't have as much, how do I say this, inherent dihedral. And I'm not going to go down that rabbit hole yet either. So then we start talking about a plane that is easy as far as stability, but it is a higher performance. So you might have a fully symmetrical wing. It might be a go-fast plane. And if you don't know this, an airplane can stall at any speed. You know, I don't know how many times I've heard people at the airfield arguing, you know, it's going plenty fast enough, it can't stall. And if you get the angle of attack, and just so you know this, relatively speaking, most wings will stall at 15 to 16 degrees of angle of attack. And that's a pretty much given at point where the wing quits to fly. Most of us would never have that much pitch up relative to the way we're going. When you come out of a loop, though, sometimes, if you're not coming onto the power and you're keeping the power back and then it snap rolls and crashes, everybody goes, hey, my radio took a crap. You stalled the airplane. You can stall a plane at any speed. And that's the reason when you've got a higher cube wing load and you've got your throws maybe too far, that, you know, you're cranking back and you don't realize that you got the angle of attack way up on that wing and the plane's falling out of the sky. So there are so many things to think about when you're thinking about stability. And I'm going to keep hammering, make sure your radio is set up right. Make sure your throws are set up right. Make sure that CG is right. Now, if you scratch build an airplane and you look at the size of the horizontal stabilizer, let's say you want a small horizontal stabilizer. Make that tail a little bit longer. When I look at the 109 here, I always am amazed. Same thing with the Spitfire, how small the horizontal stabilizers were. You know, I like to be in that 25 to 30%. This is less than 25%. I think this is something like 19%. But it had a long tail, so it was stable. Okay, and I hope I'm not confusing you all. I hope I'm trying to keep this as generic as I can, because everybody wants a mathematical formula on how to build an airplane, and there isn't any. I mean, there is if you're going to spend months and weeks and do all the garbage and all that stuff. There is, but there's not a simplistic way to just do math and say, okay, I'm going to build me a Frankenstein plane, and I followed all the math perfect and it still flies like crap. It's probably your radio setup. I don't know. I don't know any airplane except one that I flew that the actual airframe was designed so bad that we couldn't get it to fly good. And it was a big delta, and the person didn't realize that deltas still have to have a little bit of a curve or a little bit of something to get the chord right. And I'm not going to go into all that. Normally most deltas or flying wings have a little bit up elevator all the time that they're flying. And I'll discuss that in another video. I don't want to go down that rabbit hole either. Corsairs have a long tail, a lot of square inches in the horizontal. I still call this a performance aircraft. But this is where you got to start thinking about things when you're thinking about how big your horizontal stabilizer is and what type of stabilizer it is. A stabilator means the entire stabilizer is moving. And I have helped at least 10 people get their EDFs or their planes, and I'm not talking about an ARF, trimmed out. If you look, most stabilizers only go up about 25 degrees and down 15 degrees. The reason they do that is you have a huge amount of moment there. On the full-scale aircraft, the reason they have that is if the plane happens to go supersonic by accident, or it's intended to go supersonic, the stabilizer still has control of the pitch. Planes with an elevator that goes supersonic, the shock wave, I'm not going to get too nerdy, basically makes the elevator ineffective. But a stabilizer stays effective. But when we build models, we're not going supersonic, are we? I hope we're not. But when you look at the A7 here, that's an awful lot of wing. The real one did that to carry big, big bombs and lots of bombs. But if you think about the proportions of that tail, that's still a long tail to have a stabilator. So keep in mind, the longer the tail, the more oomph you got or more torque you get on that center of gravity point. So, and the reason I'm saying this is because there used to be, I think it was Jet Hanger Hobbies. I had the 46 size OS version of this, and a friend of mine had one. His flew like garbage until, and this was an old Airtronics radio, but we ended up only having about 15 degrees of up a stabilizer and about 5 degrees down, and it flew on rails. But when he had like 30 degrees up and 25 down, it was almost unflyable. And the CG was actually a little bit nose heavy. When you think about the F8 or 7, whichever plane this is, I always forget, I think it's F8, had a really long tail. But again, people don't understand how a stabilizer works, or they build these two planes really heavy. Okay, I don't know how many times people say these planes are unstable. It's not the airplane's fault. It's either been built too heavy or you've got it set up wrong. Okay, and then we go into what I called code red. So it could be a bad design, probably not. CG could be off. It shouldn't be if you know where the CG is. The throws, make sure that they're somewhat tame, and then make sure your incidences are right. I had a friend build a Zeroli plane one time, and every time he landed, he goes, "David, look at my trims." And he had about 3 degrees down trim on the elevator. And I said, "But it flies great." He goes, "Yeah." He goes, "Something's just not right." We looked over the whole plane, checked the CG, couldn't find anything wrong with it. Finally, a couple of weeks later, he brought it over to my house, and we set it up on a jig and checked all the incidences. And he actually had about 1.5 degrees, I think it was, of the whole horizontal stabilizer. The nose of it was down, so it was making the plane always want to climb. So he had trimmed in down elevator, and the plane flew fine because the CG and everything else was good. And it wasn't worth cutting the tail off and fixing it. But I will tell you one that had to be fixed. My MSL-1, my vintage airplane with the sewn-on fabric with all the rigging, on the test flight, the plane flew with an attitude like this. And my spotter over my left shoulder kept saying, "Get your nose down, you're going to stall." And I'm like, "It won't climb then. If I put the nose down, it loses altitude." I said, "I think my wing incidence is off." Everybody who saw the plane, I could hear people yell, "Get your nose down, you're going to stall." Well, we ended up doing 3 flights that day so I could get my AMA waiver. But then I went home, and the rear of the wing where it connects to the fuselage, I dropped each of those 1/2 inch. And then from there on, the plane flew perfectly level. So what had happened was I had a flat bottom wing, but my leading edge wasn't really a Clark Y. The leading edge came almost all the way down to the bottom of the cord. So if I would have drawn a line through the angle of, well, the incidence angle relative to the thrust line of the airplane, I was barely above 0. That's the reason the plane needed about 2 to 3 degrees of nose up just to fly level. And it looked stupid in the air. The plane literally looked like this the whole time it was flying. So that's where it matters. Okay, if your incidences are right, the CG rights, and your radio throws are set up right, it's hard to build a tail or a plane that's unstable. Okay, I'm not saying it's impossible. If you end up with like wing warp or twist or anything funky like that, that goes back to the structural strength of the airplane. But as I wind this down, I do want to show you something that, this was one of my very first planes that I called Frankenstein. This wasn't completely scratch built. This was a 1-engine trainer that I made into a twin, and I stuck that funky canard on the front of it just because I didn't know any better. And this plane was really unstable, and it was underpowered. It ended up becoming a tri-cylinder, and you can look up a tri-cylinder. It's where I put a motor on the vertical stabilizer down the road. But putting that stupid canard on the front of it, every time that the nose had a positive incidence, that canard caught the air and tried to pull the nose up. Then I would push it down, and once I had a negative, it would pitch it down. So the entire time I was test flying this plane, it had a porpoise to it. It just porpoised up and down. And once I broke those off, it flew perfect. So be careful you don't add things to your airplane for a cool factor that makes it fly like garbage, because that's what you don't want to do. So, you know, in the end of this video, and I know it went long, everybody, I don't know how I want to stress to you newbies and the people that are just getting into flying, just build it. You know, there's people that sit on simulators for days and then send me the data and goes, Damon, this is what my airfoil is going to be. And I'm just like, just build and fly the airplane. It's a model. It's going to fly. CG, incidences, and your radio setup right. And then make sure that you got a Q wing loading that's in a flyable range, and you're good to go. Okay? So, I hope this helps everybody, because I have a massive passion to just get you building it into the air. You know, if you want to spend all your time on a computer designing an airplane, it's probably not going to matter. The plane's either going to fly or it's not. So rock on, everybody. I'm going to wind this down. It went a little bit longer. I try to keep these things like 15 minutes, and this one's 30. I apologize. So I'll see you next time, okay? And the next one is going to be an update on the B36 series. If you've been following me, I built a B36 12 or 10 years ago, sold it. Have basically been working on the redesign of it, but I'm sharing that original build and all the techniques, but I'm also sharing what I've learned and what I'm going to do in the 2.0 version that should be coming in about 24 to 36 months that I'd start on it. Rock on, take care, and have an awesome day, everybody. And go fly. Just go have some fun. See ya.